Hello students, today I am going to explain 6th September mains shift 1 chemistry paper. So in which the first question, we have alkyl compounds, mercuric sulfate, sulfuric acid, H2O and final product. So what is our final product in this reaction? So right, here NO2. Mercuric sulfate, H2SO4. Here mercuric sulfate is commonly used as reagent in aqueous solutions. Here H2SO4 is acts as H plus. Nothing but H plus is catalyst here. So to form and here tautomerism will take place. H2O is added to alkyne in presence of mercury sulfate and H2SO4 to form. So alkene, our alkenase compound here. Tautomerism will take place here. Tautomerism, because double bond ene and alcohol, enol. So enol to ketone. So right, so this is our product. So here option 4 is correct. I didn't write options here actually, but here option 4 is correct. So this is the equation to get final product. But I want to explain mechanism also for this reaction. Right. So here H2O. Here one of the hydrogen is add this carbon, that's why here CH, and remaining OH, because H2O is like this, H bond OH, right? Here H plus and here we have OH minus. Here NO2 and methoxy. Comparatively NO2 and methoxy, NO2 is more electron withdrawing group than methoxy. That's why here this one of the pi bond shifted only towards this carbon, but not this carbon. So this carbon get negative charge and this carbon get positive charge here. This carbon get negative and this carbon get positive charge here. Here H plus is going to attack this carbon and OH minus is going to attack this carbon. That's why here we get CH double bond OH. And tautomerism takes place here to form. Here tautomerism means I told you already. So resonance is possible, bond. So this bond rotate between these two carbon, and immediately this bond rotate towards carbon. This carbon get negative charge and here hydrogen is get positive charge, and this hydrogen towards this carbon. That's why CH2 C double bond O. So this is our final product, but not this one. Of course, third option is this one and fourth option this one. So most of the students will confuse. Definitely they took a third option, but not here third option. Fourth one is correct. Next question, write down increasing order of pKb following. Here we have 4 options, in which in all 4 options NCH is taken to, NCH is taken to, NCH is taken to, and NCH is taken to. All para position of groups are same. That's why you have to depends on only methyl. Here methyl group, here cyanide group, here alcohol group. Yes or no? So generally here pKb. What is the concept for pKb? Actually pKb is used to measure basic strength, right? pKb is inversely proportional to the basic strength. Inversely proportional to the basic strength. but basic strength is directly proportional to electron density. Here what is our electron densities are generally plus M effect and hyperconjugation and plus I effect. So plus M mesomeric effect, hyperconjugation and positive inductive effect. Electron density increases, basic strength also increases. But here basic strength decrease in minus I effect and minus M effect. Yes or no? Negative inductive effect and negative mesomeric effect. So let me explain which order is correct. Right here, methyl. We know that sir, methyl is act as it is involved in hyperconjugation. At the same time, it is plus I effect. Right here, cyanide sir. Cyanide here negative inductive effect. At the same time, increase negative inductive effect here. Of course, alcohol also negative inductive effect, but it is decrease inductive effect here. So among these four options here, hyperconjugation and plus one, positive inductive effect. I told you already, positive inductive effect, hyperconjugation, increase electron density. That's why basic strength also increases. Among these four, which one is more? First option is more for basic strength order. First of all, you have to take basic strength order. So first one is more. Obviously, second one is more basic here, right? Second one is comparatively third and fourth. Compared to third and fourth, sir, negative is more negative inductive effect. I told you already, more negative inductive, basic strength will be decreases. Here less negative inductive effect comparatively third one. That's why. So fourth option here, fourth one is more basic than third one. Yes or no? So, but here we need PKB. We need PKB order. Here I told you already, PKB is inversely proportional to basic strength. So, this order is reversed to get correct option for PKB, because PKB is inverse proportional to the basic strength. That means 1 less than 2 less than 4 less than 3. That means this is increasing order for PKB. So we need increasing order for PKB. So I think 1, 2, 4 and third. So third option is correct for this one. Next question. So this is our compound. The first condition is tertiary butoxide heating. Second option is O3 H2O2 to get final product here. So let me explain what happened here. CH3 CHO SO2 CH3 here, bond CH3. The first condition is, what is our first condition, sir? Tertiary butoxide and heat. Right here. You know what? Tertiary butoxide is generally higher group. Tertiary butoxide is higher bulky group here. So immediately here I want to use one hydrogen, like one hydrogen right here. You know what? This bond rotate between these two carbon, this total part is eliminated. So to form CH3 bond CH bond CH3 CH double bond CH2 plus CH3 bond SO3, because 2 or 3 oxygens and along with hydrogen to form SO3H. Here the important point here, O3. So most of the students generally O3 means ozonolysis, but here ozonolysis in presence of H2O2, sir. So it is strong ozonolysis takes place here. General ozonolysis, what happen here? This double bond will break here. This carbon gets CHO, formaldehyde. Sorry, aldehyde. This carbon get aldehyde and this carbon get formaldehyde. Right. So okay, I wanted dummy product, but this is not correct product here. This carbon gets CHO plus this carbon gets CH2 means formaldehyde, right? So I think So third, yes, second option is correct according to ozonolysis. Yes, second option is correct. CHO, right? So here also CHO and HCHO. But that is the wrong option here. Because this is oxidative ozonolysis will take place here. Oxidative ozonolysis will take place here because strong oxidation. So here bond breaks are here. Immediately this form CH3, CH, bond CH3, COOH, carboxylic acid. And the end of the carbon will get formic acid. Strong ozonolysis will take place here, right? So at the end of the carbon will get formic acid, and this is the main compound here. So third option is correct, right? So CH3, again CH3 and CH, bond COH, HCOH. So that's why third option is correct, but not second one. Next question, which can show geometrical isomerism? So only one concept, sir. Double bonded carbon, alkene, and at least two groups are same, right? Only two key points here. One must be alkene and second must be at least two groups are same, or at least two atoms are same. Here all are double bonds, sir. 4-methyl pent 1 in, 4-methyl pent 2 in, 3-methyl pent 1 in, 2-methyl pent 1 in. And the one of the predominant condition for geometrical isomerism, end of the double bonded carbon will never exhibit geometrical isomerism. End of the double bonded carbon. Strictly, yes, end of the double bonded carbon, end of the double bonded carbon, here also end of the double bonded carbon. That means these end of the alkenes of carbon will not show geometrical isomerism. Only second option is directly can say that correct option. Why? Because sir, end of the carbon is always to form. Here what are 1, 2, 3 and 4. Two terminal hydrogens are there. Yes or no? For example, double bonded carbon like this. A, B, B. Right? Here also double bonded carbon. So B, B and A. Which can show geometrical isomerism, sir? So this is never show because this is a terminal arrangement. But this is adjacent arrangement around the double bonded carbon, right? So what is the definition for geometrical isomerism? Same structural formula but different isomer. That means the same structural formula, the spatial arrangement of the groups around the double bonded carbon. Spatial arrangement, but not spatial arrangement here. Spatial arrangement restricted is free around the double bonded carbon. Rotation is free. Right, at least two groups are same, sir. So the adjacent, if the same groups lie on the adjacent position, they are called cis. If the two same groups lie on the opposite one, that trans. So here opposite, adjacent carbon but not terminal carbon. So this is called adjacent but not this one. So this will show geometrical isomerism. This will not show geometrical isomerism. Same happen in first option, third option and fourth option. That's why second one is correct because this is not a terminal, end of the carbon. Next question, if concentration of fluoride ion is up to 1 ppm, then which of the following option may be correct? Here 1 ppm parts per million. You know what? Fluoride ion up to 1 ppm is not so harmful for the human beings, but more than 2 ppm it is harmful. 5 ppm is more very dangerous to the human beings. So of course it is good for teeth. It's the correct option. Next question, which of the following lanthanides element do not show +4 oxidation state? Here europium, dysprosium, terbium and cerium. So terbium symbol is Tb. Terbium, cerium, dysprosium and europium. You know what? They are all belongs to lanthanides. And the most common oxidation state for lanthanides is +3. So that is the first case in this case. +3 is oxidation state for lanthanides. However, some of the elements can show different oxidation state also, especially these four. You know what? Here europium, the outer electron configuration is 4f7 6s2. Dysprosium 4f10 6s2. terbium 65 atomic number 4f9, 6s2, and cerium 58 4f1, 5d1, and 62 6s2. So these are outer electron configuration for these elements. You know what, here europium is already half filled configuration is there. That's why europium is more stable comparatively this one. That's why it is ready to lose only 2 electrons. That's why this can show +2. Remaining all are can show +4 also. But because they are not, it is incompletely filled, and it is also incomplete fill f orbital. F orbital incomplete fill. All are incompletely filled f orbitals are there. That's why they are of course +3, but they are ready to show also +4. In this case, you need to keep your mind one point here. Actually, if all elements in lanthanides try to attain +3 oxygen state, because that is the most common oxygen state for lanthanides. So here, europium also the tendency to possesses to attain +3. +3 means it is lose 1 electron. That's why it is strong reducing agent. So cerium is also act as strong reducing agent. So that is one important point here. And their gain 1 electron, right? By gain 1 electron to attain +3. So gaining of electron nothing but here also it is act as strong oxidizing agent. So dysprosium, terbium, and cerium acts as strong oxidizing agent. So okay, according to part of the question, which do not show +4 oxygen state. So europium, the first option is correct. So it is only +2 in aqueous solution. Remaining also +4 in aqueous solution, right? So +2 is europium is the correct option. Next question, values of equilibrium constant at 2 different temperatures is given as 2 different temperatures. T1 50 degrees centigrade and T2 100 degrees centigrade. Equilibrium constant K1 10 and K2 100. Okay, here 50 to convert Kelvin plus 273 should be added to the 50 degrees centigrade to get 323 Kelvin, and it is 373 Kelvin, right? So then the values of delta H of reaction at G1 and G2 in kilojoule at temperature T1 and T2 respectively, right? So this is a lengthy explanation question, sir. First of all, you need to find delta H, then after to find G1 and G2 in kilojoules at temperature T1 and T2 respectively. So how to solve this question? So with the help of Watt-Off equation, we know that Watt-Off equation very well known. So log K2 by K1 is equal to delta H by 2.303 into R 1 by T1 minus 1 by T2, right? So substitute here log K2, what is the value of K2 here? 100. So 100 by 10 is equal to delta H by 2.303 into 8.314. So into 1 by T1 how much are here? 323. So 323 minus 373, right? So delta H is equal to, you need to find here delta H, sir. Yes or no? You need to find here delta H here only. So delta H 46 after works out you will get 46136. Yes or no? 46136.5. This is joules, sir, but we need kilojoules. So by 1000 you will get 46.136.5. You can write 14 also correct answer. Yes or no? 46.14 kilojoules, right? So this is delta H for changing enthalpy for this reaction. But you need to find delta changing Gibbs energy and one changing Gibbs energy 2 at T1 and T2. So of course we know that delta G is equal to minus 2.303 into RT1 log K1. Yes or no? So RT1 log K1. Yeah, G1 T1 K1 because delta G1 at T1, delta G2 at T2. That's why T1 and T2. So delta G1 is equal to minus 2.303 into R value we know that 8.314 here. What about T2 once our temperature T1 323. So 323 into log K1. What is the K1 value? Log 10. Of course, log 10 is only 1. So delta G1 is equal to, right? Delta G1 is equal to minus 6184. Minus 6184 0.5 joules is there, but we need kilojoules. That's why by 1000 minus 6.184 kilojoules. Okay, this is G1, sir. Coming to find delta G2. So minus 2.303 into RT2 log K2, right? So delta G2 is equal here minus 2.303 into 8.314 into T2, sir, 373 into log 2. Log 2, sir, 100. Sorry, log 100. Yes or no? So after works out, you will get delta G2 is equal to, so minus 283.7 joules, but we need a kilojoule here by 1000 minus 14.283.7 kilojoule. So this is delta G1 value, this is the delta G2 value, and this is delta H value here. Of course, so what are the options we have? Actually, option 1 is correct one here. What is option 1? 46.14 comma minus 6.2, right, comma minus 14.3 here. Option 1 is correct, sir. Yes, 46.14. Yes, 46.14. Delta H. This is for delta H. What about delta? This is G1 and delta G2. What about delta G1, sir? Minus 6.2. Yes, minus 6.2. 18 means, can I write here 1, 2? Yes, right. Total. Yes, so the round figure value. Significant value in this case. Minus 6.2 here. What about delta G2? Minus 14.285. Minus 14.285 in the sense nothing but 285. The sense means here directly you can write minus 14.3 kilojoules. So here significant values also you have to remember. Yes. So that's why this is the first option is correct for this one. Question: identify correct set of atomic numbers belongs to transition element series. Right? Most of the students definitely will do mistake in this question because all d block elements are not equal to, not for transition elements, right? What are the electron configuration for d block? N minus 1 into d, 1 to 10 ns2. This is for d block. But what about transition elements? N minus 1 into d, 1 to 9 ns2. 1 to 9 only. Up to 1 to 9 that belongs to incompletely filled subsets of transition elements that belongs to of d block elements that belongs to transition elements. So that means 1b, that means third b to 1b only, but not 2b, right? So zinc, cadmium, mercury and copper-lithium. So they are the these four are not belongs to transition elements, right? Right here, among these four options, first one is direct, you can say elevated from this set because 9 is fluoride. So atomic number 9 is that's why first option is not correct for this case. And coming into second one, 21, 25, 29, 57. Yes or no? So next coming into third ones are 21, 25, 30 and 57. 29, 48, 57 and 72. Yes or no? You know what here? 30. Atomic number 30 is nothing but zinc, sir. Here atomic number 48, this is cadmium. I told you already, zinc and cadmium are not transition elements, they are d block elements. So that's why you can directly say that second option is correct one. 21 scandium, 25 is the manganese, and it is copper, it is lanthanide. So lanthanide is belongs to transition elements but not F block element. The F block series is starting from, that means 4F series. 4F series starting from lanthanum, that's why they are called lanthanides. So lanthanide is not belongs to F block, it is belongs to D block and moreover transition element. That's why, so second option is correct. Next question, missiles formation takes place. Very easy question, missile formation takes place here. Direct say that second option is correct, sir. Here second is one, I didn't write option, remaining option here, but second one is correct. What is second one? Above craft temperature. Of course first option is below craft temperature is there, right? Here above craft temperature is correct. Craft temperature is correct. What is the meaning of here craft temperature? Missile formation takes place at a particular temperature is called craft temperature. The symbol is TK like this, craft temperature here. So missile formation takes place at a particular temperature is called craft temperature. That is always above but not below. And one more thing in this case, CMC, critical missile concentration, it is also above but not below. So above critical missile concentration, missiles are going to be formed but not below CMC is not possible. Here also above craft temperature is possible to form missile formation but not below craft temperature. So that's why second option is correct one. Next question, following graph obtained for 4 different reactions. Here log rate versus log concentration. We have 4 rates are there, A, B, C, D, right? And on the basis of this, on the basis of above graph, correct increasing order of reaction. We know that rate is directly proportional to concentration of the reactant to the power of n. Here n nothing but order of reaction. So rate is equal to your constant to the power of concentration to the power of n. So taking logarithm on both sides, what happens here? Log rate is equal to here log k into concentration to the power of n. So log rate is equal to here log k into concentration to the power of n. Log a into b formula, log a plus log concentration to the power of n. Again log rate is equal to here log k. Here log concentration to the power of n, log a into log a to the power of m log a. So plus n log concentration. So this is our reaction here. According to straight line curve equation here, y is equal to, so mx plus c. So here y is nothing but log rate. Yes, log rate. So here x log concentration. Yes, log concentration. Here intercept is log k, but slope is n here. Here n is slope. So here n is here our slope, which is nothing but m. So then what do you understand? What do you understand in this case? So slope of graph is order of reaction. Yes or no? Slope of graph is order of reaction. So greater the slope, so greater is order. Yes or no? Greater is the slope, greater is the order of reaction. Yes or no? So that's why here more slope is D and C, B, A. So option is option 1 is correct. Yes or no? A, B, C, D. High more slope is D. That's why this is an increasing order for this one. So first option is correct. Question: which of the following complex show magnetic moment spin only is 5.91 bm? So so this is continuation question, sir. So 5th September SHIFT-1 is also one of the question is there, like this question based on magnetic moment. Here also, see now 6th September also morning SHIFT-1 question is there. So that's why, so this is very important concept. So magnetic moment 5.91. Here what is the meaning of 5.91, sir? In the sense here 5 unpaired electrons are there. I told you already in my previous class. So 5.91 Bohr magnet nothing but 5 unpaired electron. Because I have already told you magnetic moment is not a fixed, it is a range value. So 5.91, 5.93, 5.83. So all are correct here. So the what is the number? 5 is the correct answer. That's the 5 unpaired electron. So here among these 4 options you need to find 5 electrons are present in which complex. So first option is wrong option, sir, because here carbon monoxide is a ligand here. It is a neutral ligand. So that's why it is 0 oxygen state. So first one is directly eliminated among these 4. Second one is F6. Second one is F6. Fluorine is a weak field ligand. Here this is weak field ligand. So here fluorine get +3 oxygen state. That means actually 4 in atomic number 26. So that's why here 3d6 4s2 configuration. But according to this complex +3 oxygen state you will get. That's why here 2 electrons will lose. Here 1 electron will lose here. So 3d5. So weak field ligand. What is the meaning of here weak field ligand here? No electron causing pair here. No electron causes pair. Because weak field ligand is not to capacity to pair in d electron. If it in the sense, for example, here FCN taken 6, cyanide is strong field ligand. So here also iron get +3. That means so 3d5 4s0. But 3d5 means 1 2 3. So 1 2 3 4 5. 5 electrons are there, but here cyanide is strong field ligand. That's why initially these 3d5 electrons are going to be paired. That means so this is happened. So here how many unpaired? Only 1 unpaired electron. So that's why here. So here whenever in complex coordination complex, so ligands also can create key role in this case. So that's why here strong cyanide is strong field ligand. That's why here these d electrons are causing pair in this case. But here fluorine is a weak field ligand. That's why d electrons are not pairing in this case. That's why here 5 electrons, here only 1 electron. That's why second option is correct. Which of the following is not correct for alloy? You can direct say that German silver, brass, bronze and bell metal. Among these 4, so brass is correct option for this question. Coming to 14. How many total number of Cl double bond O bonds are present in structure of perchloric acid? Formulas are HClO4 is perchloric acid. Structure chlorine double bond O, double bond O, double bond O, O bond H, because chlorine is 7 valency electrons, because it is belongs to 7 3 group elements. 1 2 3 4 5 6 7. So C double bond O, C double bond O, C double bond O. So total C double bond O. Total C double bond, sorry, chlorine to double bond O, Cl double bond O. Total Cl double bond O is 3 bonds are there. So it is integer type question. That's why you can write 03.00. 03.00. So 3 is the correct one. Next question. Statement 1. HDP, high density polythene, is when addition polymerization of ethene takes place in hydrocarbon solvent in the presence of catalyst Ziegler-Natta at a temperature of 333 to 343 Kelvin at pressure 6 to 7 atmosphere. Statement. HDP, high density polythene, consists of a linear molecule and has high density due to closed packing, and it's used for manufacturing board buckets, dustbins and bottles. Regarding this statement, yes, both are correct, sir. Because high density polythene we are using 6 to 7 atmosphere, high pressure we are used to this case. That's why statement 1 correct. So here high density polythene means they are linear structures, linear molecules are there. That's why due to closed packaging structure, so to manufacturing bottles, dustbins are there. So that's why statement 1, statement 2 both are correct, and statement 1 and statement 2. Statement is correct explanation for statement 2. So that's why option 1 is correct.